Hello, my name is Rexy. In here, me and my group will explain about Turing machines. There is Farel Rivaldo, Mohammad Haikal Aiman, Muharrir, and Rexy Noverta. From the video of Computer File YouTube channel, Assistant Professor Mark Jago explains about Turing machines. What is a Turing machine? Back at the start of 20th century, mathematicians were fascinated by the questions, just how much maths can we do? Not by using our guts, feelings, or intuitions, but just by following rules very, very carefully. By following an algorithm, in order to make that notions precise, we would have to set out just what do we mean by a program or algorithm. And this is where Alan Turing came in with his notions of Turing machines. Turing was working on a problem, a logic, and as a part of his proof, he had to come up with the notions of any possible algorithm or any possible machines. He had to come up with a very general way of capturing how algorithms or programs or machines would work. This is where his notions of Turing machines comes in.
So, next I will explain about how does Turing machine work. To make the Turing machine can work in the coded form, we can start thinking from making the tape. It can be finite tape or infinite tape based on the what we need. And we can write it into a square, and inside of the square it will depends on the digit that we want. It can be either 0 or 1, or it also can be the spaces. So next, here is the example of the Turing machine image. So the way how Turing machine in this image can work is it will look into the tape on one square at a time. In here we have finite tape that contains 6 squares, and then we can imagine it by thinking that there is a little box looking at one square in a time, which is the box with yellow circle, and then that little box will be coded up or find the solution from our problem that we want to solve.
Thank you, Rexy. So, moving on to what it does. What a Turing machine does is actually quite simple. At a certain time, it's in a particular state, which is looking at a square on a tape, while having a logbook or a program book to tell the machine what it does if such conditions occur. For example, if the machine is at state number 2 and on the square is written 0, then change that 0 to 1 and move to the right and change the state to number 5. When the Turing machine follows these sets of instructions, it will follow it accordingly. I will perform the next set of instructions that relates with the conditions of the next state.
Thank you, Harir. So that is basically the process of Turing machine. The process itself is so simple, but it is the essentially the most basic iteration of computation. Whatever today's computer can do, in theory, a Turing machine can also do. A system of ones and zeros on a tape. This is why Alan Turing is widely considered as the father of theoretical computer science and artificial intelligence. The Turing machine is the blueprint for manipulating ones and zeros to solve problems. This simple idea is so effective that all modern computers do exactly what a Turing machine does. We use this idea to evaluate programs. When a computer programs can do what a Turing machine can do, it is dubbed as Turing complete, the strongest program that we can have, best of the best. Thank you.
Next, from the point of view that has been explained by my friends, we can assume that anything that computer can do, a Turing machine can do. And a challenge comes from a quantum computer which always seem they can do all the things magically. Quantum computers can be modeled in several different ways, such as the quantum Turing machine, and everything compatible using quantum computers is also compatible using classical computers. And so, from the point of view of compatibility theory, Quantum Turing machines are just another equivalent model. However, quantum Turing machines are widely conjectured not to be polynomially equivalent to classical Turing machines. In a simple way, the quantum computer can do more than a Turing machine, but it can do the things more efficiently. For a brief example, if you ask a classical computer to find out your phone number in a phone directory, you have to look it for every single entry, and it would take a long time. But a quantum computer can do it more efficiently. Thank you so much.